Okay, part 5, lecture 4, definition of covariant and contravariant metric. You see, this is the vector space, okay, which I mentioned in part 4. This is the basis, okay, the basis vector. Now, this is called in the literature as a product, tensor product. That's just a name, okay? This is a tensor product because it's not a dot product, it's not a cross product in this case. So this is called tensor product. Tensor product. Now, you see, attention now, G is invariant. This is invariant. This is equal to G, you see here, G ij ai tensor product ej. You see, that's a basis. This here belongs to this space here, the vector space, okay? And this is equal to G. Now, you look at here, you have G ij I tensor product J. See? This is invariant. Now, Gij contravariant, they are the components of this tensor here. This here contravariant component, okay? This is covariant component. Or the same, it is a invariant tensor product, the second tensor product, second order. Now, let's consider the dot product. You see, AI dot AJ is equal, by definition, Gij. Then AI dot AJ is defined as Gij. You see? Look, attention now, this is a dot product. Why is a dot product? Okay? It's not inner product. It looks like an inner product. Because here you are deriving using curvilinear coordinates. You see, that's a very important. This is different from the part 4, which we didn't talk about dot product. We didn't set an arrow on the basis. Okay, but here it's clear that we are deriving using curvilinear coordinates. You see, as I pointed out on the lecture 3. Now, you see, important property of the G components. Now, this is the vector space. This over here is the dual. Okay? So I can suppose a vector v over here. See, this is different from this. The same vector here is the vector v. Okay? That's just a notation. Okay? So I can write the vector v, this is equal to vi ai. You see? The vector v, okay? Now in this vector space over here, okay? This is dual, okay? Don't forget that. This is a vector space. This is a dual vector space. Okay? Now, you see, I can expand this vector v in the vector space just using this basis vector and vi. Okay? See, it's not confused. This vector v doesn't have nothing to do with this v over here. Okay? Now, these are, in this case, contravariant components of the vector v. The same vector v, I can write as, for instance, vj aj. You see? These are the components, okay, of the vector v, the same vector v. You see, I'll put in red here. Okay, there's red. Okay. This is v. There's the same vector v, which is invariant. So I can write here as vj ej. You see? This is the vector v. Okay? You look at here and look at here. Okay? It's not confused. Don't confuse this with this v over here. Now, thus, I can write v I ai dot ak. You see? vi ai dot ak. So this is equal. Then I'll have vj aj dot ek. It's quite simple. See, just look at here. This is invariant. Don't forget that. You see, this over here, I'll emphasize this invariant. See, the same on the vector space, the same v on the dual vector space. The components are different, but the vector is equal. Now, what is this? This is GIK. What is this? This is delta JK. You see? Then I can write that VI is equal, just copy from here, you see, delta GK, okay, on this side over here, okay, this is VK, you see, delta JK, okay, the drops, in this case, J, okay, and put K. Here, then I have VI, I'll write this, is better. Okay, VI, I just copy from here to there, okay? GIK is equal. Now, the property of delta, conic delta, okay? This is equal to VK. You see? The property of delta JK, this is J, okay? This is J. You see, I drop this and put that. This is a very, very important property, okay? Because GIK we call a contraction, okay? Why a contraction? Because I have a second order tensor here, it contracts I here. Just drop this, skip, okay? That's drop. Drop I and set K. But here, look how interesting. This left hand side, VI, is contravariant, and this is covariant. You see, remember this. This is covariant component. This one is contravariant component. So this, you see, GIK is a little bit different from delta. Delta, we just look at this place here and substitute here. GIK, he look at I, okay, and transform